Okay, so I have recovered from what just happened just then. If you watch my previous video of me trying to draw a tan graph and fail, if you're looking for some entertainment, that may be something you can watch. But we're going to maybe try to make things really exciting for 10 and let's solve it. So, all right, it's 10. What looks good? I really hope I get an answer because a lot of time when I do this, I don't have an answer because the answers are like outside. I don't have any answer in the restricted domain is what I'm trying to say. So I really hope it works this time. Let's go to maybe 4 pi on 3 minus 2 pi. Oh, this is terrible. Okay, what should this equal to? What looks good? 1. Negative 1? Negative 1. Negative 1 it is. Okay, so 10 of that equal to negative 1. The method is very, very similar to what we talked about before. And this is my method, you don't have to use it, but I normally think of what is inside the bracket as the angle, so I would solve for the angle first, probably want to put the actual variable in, and then I will solve for x. Okay, so basically you can rewrite this as tan of the angle being equal to negative 1. And I'm going to think about what the restrictions will be on the angle based on the restriction of x. So 0 less than or equal to x less than or equal to 2 pi, and then minus 2, so 0 greater or equal to x greater or equal to negative 4 pi. Make sure you flip the sign of inequality and then add 4 pi on 3 onto it. I hope this works. This is a fairly large domain, so I think we're actually going to have a few solutions this time. I can't do math. What is this equal to? I don't know. What's 4 pi on 3 minus 4 negative 8? Wow, that was really slow. Sorry about that. Okay. Yep. Let's start with the base angle. So the base angle is pi on 4 because tan of pi on 4 equal to 1. I'm going to use the unit circle method again. So pi on 4 is around here. Oh, this one works out really well. So we can just assume, all right, so that's 1 and that's 1, even though it's not. So that's the gradient of this line. So if you want negative 1, you need to go to the other quadrant. So you're basically drawing a line so you can use here or here. And I really hope some people remember this, but these two lines actually will be perpendicular to each other because the gradient will add up to negative 1. Okay, so this angle, it's going to have a gradient of negative 1, and this angle is going to have a gradient of negative 1. And this bit here is supposed to be pi on 4, and this bit here is supposed to be pi on 4. So let's think about what angle that you're actually going to take based on the restriction that we worked out here. All right, so negative 8 over 3, sometimes it makes it really hard for people to figure out what's going on. So it may be easier to actually write this as, so this one's pi plus pi on 3, greater or equal to the angle, greater or equal to negative 2 pi minus 2 pi on 3. Okay, oh, this is good. So I'm gonna start because I think this is the first example that I'm using that actually is giving you negative solutions. So let's just, it's up to you. You can think of it as two ways. So you can start from 0 to pi plus pi on 3, and then you can cover the bit from negative 2 pi minus well, from 0 going back to negative 2 pi minus 2 pi on 3. The reason why I'm going to separate this into two different intervals is because for the first one, you're going to go anti-clockwise because you're going positive. And for the second one, you're going to go clockwise. Okay, so anti-clockwise and then clockwise. So let's start with the anti-clockwise ones. I'm going to go forward. I think my limits are somewhere here, so I can take this angle. So this angle will work, and this angle is my first answer for the angle, which is going to be can do maths at 3 pi on 4, and I think that's the only angle that I cannot go down here. It's going to be way too big. And then I'm going to go back, and I think the going back is actually going to be fairly exciting. So you can take this angle. This is the first one, because you can go a full circle back and then a little bit. Then you can go to here twice. Okay, so that's the first one. So that's negative pi on 4. And then I can take this angle, which is going to be negative 5 pi on 4. Okay, and then I can take this angle. Sorry, I'm going to use a different color so you can see. Basically, because I'm allowed to go back more than one whole circle. So let's go. All right, so this is going to be negative 2 pi. Let's try again. This, if I go from here to here, that's negative 2 pi, but I can go down to here. And that should still work because negative 2 pi on 3 is somewhere in the third quadrant. Okay, so I think this is my last answer. I don't think I can go up here. Anyway, this is going to be, this is actually, I cannot do anything. Negative 9 pi on 4. Can't do maths is what I'm trying to say. So negative 2 pi, and then you go further back a pi on 4. So that's negative 9 pi on 4. Alright, so that's the angle. Now you're going to solve for x. Just do transposing essentially. So I'm just going to rewrite 4 pi on 3 minus 2x would equal to this. I'm not doing any calculation here. All I'm doing is rewriting it so I know what the angle is. Alright, so you probably want to solve for 2x first. Okay, I'm going to solve for negative, it doesn't matter. Okay, so 7 pi on 12, and then that is something, 19. Ew, what is this? Did I even do that right? I think so. Comment below. Actually, I don't know where I'm putting these videos. Oh my god. Ew. 4. Oh. What number? Okay. Wow. And then you double the denominator, you're done. Hang on, is this thing correct? I did that. 16, 27. Yeah. Alright, so x. Let's hope this works. 7 pi on 12. So 24. 19 pi on 24. 31 pi on 24. And 43 pi on 24. Notice how they all fit within the original domain, because the original domain is actually going to be 0 to 48 pi on 24. So everything actually still fits. It's magical. That's it for this question.